like to welcome everyone. Um, today, good evening, everyone. And I'm so pleased to share and welcome that Mr. Partha Majumdar has joined us to the platform, and he will be conducting an expert session in the area of business analytics. And the topic of today's session is applying machine learning for detecting malware in JPG files. So before we begin with the session, let me briefly introduce Mr. our expert speaker for today's session, Mr. Partha Majumdar. Mr. Partha is currently working as a vice president in JP Morgan. He got a vast experience of around 32 years in creating enterprise class computer softwares for various ministries and government bodies of several countries and for more than 20 enterprises. He has been involved in large projects around the globe. We welcome you here, sir, on this platform. And I'm sure we are going to have a great learning today from your expertise.
Thank you, madam.
Okay. So you can start with the session, Mr. Partha. You can start with the presentation.
Okay. Okay. Good evening, everybody. Welcome to this session. Now, this session, as Madam has told, that this is a session on business analytics. So we will see one aspect of business analytics, how it is applied in the industry. Now, this is a technique which I have developed, and I will tell you what is the extent of this and uh, to where do we stand in terms of utilization of this technology. Now, we will see in how much time we have. If we have enough time, then I will also walk you through the code that was utilized to generate the results, what I will share with you. So let's see how it goes and how much we can cover. So like we were discussing, just 1 minute, let me flip the slide. Yeah. Now we are talking about business analytics. Now business analytics basically deals with any kind of treatment of the data. Now this actually starts from data collection to data uh, massaging to data utilization for generating inferences and conclusions. So anything to do with data actually comes under business analytics, and we extend in recent times this has been extended to also make predictions. So making predictions, making prescriptions, etc., everything comes under business analytics. So we will take on one aspect of business analytics today, that is predictive analytics. So we will try to make a prediction using some data that we have in our uh, uh, grasp. So while making predictive analytics, while making predictions from data, we utilize basically machine learning. Basically, what we're doing is that we are giving the data to a machine, and the machine is utilizing the data in some form, whether in known form or unknown form. We will see different forms also. The machine is utilizing the data and then drawing conclusions for us. So basically we want the machine to be able to work like a human, and we are trying to train the machine to work like a human, and that is what we understand as machine learning. So we will be utilizing one aspect of machine learning, and we will see how that can be leveraged. Now, machine learning, there are primarily of three types. One is known as the supervised learning, one is unsupervised learning, and one is reinforcement learning. Now, in supervised learning, what we do is that we feed the data to the machine. We tell the machine, like, this is the data based on which you make your learning. So when we feed the data basically has two aspects to it. One aspect we know as the labels, and one aspect is the parameters. So let's say for example, we are making a system like they have done in Dubai, where as you walk on the streets, they can make out whether you are a happy person or you're a sad person. So now that is something useful for them, because if they detect that you are a sad person, then they will be cautious about you from some central location, so that you don't do any untoward incident. So now how does it happen? So what has happened is that they have taken huge number of pictures of people, Now these pictures basically are of happy people and sad people. Then someone has sat down and labeled the data saying that this picture belongs to a happy person and this picture belongs to a sad person. After labeling the data, they have fed the entire pictures to the computer, and the computer has told that, see, these are happy people, these are sad people, you learn from it. After the computer has learned, then when you show him a new picture, he says, okay, this fellow is happy and this fellow is sad. So that is what we know as the supervised learning. So we provide labeled data to the computer, and then the computer starts making inferences. Now, unlike supervised learning, in unsupervised learning, we do not provide labeled data. So we just provide the data and tell the computer to understand whatever he understands from the data. Normally, we utilize it for clustering. Let's say we give him data and say, okay, find similarities and group the data into different groups. So this is one example of unsupervised learning. In reinforcement learning, what we do is that we have a model. Let's say for example, we have a automated automated car which is developed in USA. Now this automated car is basically a machine learning model which basically knows how to drive by itself. Now once this car is brought to India, let's say, then this machine has to be retaught as to how to drive itself in India. It cannot be that automatically the car will start driving in India just like it was driving in USA. So there, the parameter, the environment, etc., would have changed. So there, this is a typical example where we have to again do a reinforcement learning for the machine so that he is able to now drive in the new circumstances. So what we will discuss today is a supervised learning model. So we will see how we can build a supervised learning model. So I will now focus down supervised learning. Now in supervised learning, we can solve two type of problems. Basically, there are two type of problems that we can solve. One is known as the regression problem and one is known as the classification problem. In regression problem, what we do is that from the data, we try to make a prediction for something which is going to happen in terms of a quantity. Like for example, I give the data regarding the rainfall in Mumbai for last 10 years, and then I tell the machine, tell me how much rainfall will be there in Mumbai on 12th of January 2022. So now that is what the machine will be able to tell you. This is typically a regression problem. Or I give the machine stock prices for the last 10 years and tell the machine, okay, fine, tell me the stock price, what will be there on January 31st, 2022. So this is typically a regression problem. Now in regression, basically what we require is that we require a continuous variable. Now continuous variable is something, okay, if you look at the mathematical definition of it, it basically says it is it is an uncountable set of numbers. So if a variable can take a number which is uncountable, then it is a continuous variable. On the other hand, when we have a variable which is countable, uh, then we call it as a and we make prediction on that variable. Then we call it as a classification problem. Now we can understand this difference between continuous and discrete variable simply like a discrete variable is a countable set of numbers, or it can be countably finite or countably infinite. Like countably finite means I have very definite numbers like cat, dog, mouse. Like let's say this is countable and countably finite. But if I say that the countable number set is uh, what do you call a set of natural numbers, that is 1, 2, 3, 4, 5, 6, extending up to infinity, then this is countably infinite. I can still count, but it is infinite. On the other hand, a continuous variable is uncountably infinite. It cannot be counted because in mathematics we know that between any two numbers we can always find another rational number. So that is the difference between regression and a classification model. So when the variable is infinite, uncountably infinite, then we say the problem is a regression problem, and when the variable is countably finite, then we say the problem is a classification problem. Now, in our case, we will be doing a classification because we want to get two results, whether the file contains a virus or file does not contain a virus. So we have countable number of outcomes. So it is a classification problem. So we will now discuss more about classification problem. So we basically want to classify um, between two sets in our case, and this is being done by supervised learning. So what we will do is that we will feed the computer with data regarding what is uh, malware and what is a clean file, and then tell the computer you learn this pattern by yourself. Once you have learned, when I give you a new data, you should be able to classify whether it's got a virus or whether it does not contain a virus. So we will now focus more on the classification problem part of supervised learning. Okay, in classification problem also, we have two type of problems. Uh, we have either it's a binary classification problem or it's a multi-class classification problem. Now, for example, if it's a spam detection problem, like whether the mail which has come to your machine, it is a spam or not a spam. So there are only two outcomes. That is either it's a spam or it's not a spam. So when the number of classes are only two, we call it a binary classification problem. So even in our case, that is, we will be wanting to detect whether the picture contains a virus or does not contain a virus. So it's a binary classification problem. Whereas there can also be a multi-class classification problem where we want, let's say we want we install a camera and tell the camera identify what are the pictures, what are the objects in the house. So it can detect a glass, it can detect a TV, it can detect a camera, it can detect an idol. So there are so many items it can detect. So when we have more than two classes to be classified, then we say that the problem is a multi-class classification problem. So we are, in our case, like I just told you, our problem is a binary classification problem. This can also be made a multi-class classification problem. We will discuss how that can happen. So let's move ahead. Now we have discussed the basic foundations of business analytics. Now let's get on to a business problem and see how this has been solved and what can be done more about it. Now, this I do not know if it is surprising for you or not, but many people whom I discussed initially while doing this particular experiment did not know that virus can be transmitted through image files. Now, this is a dangerous proposition because uh, images are exchanged by almost everybody and through all kinds of media. We send images through our mobile phones or our computers. On the mobile phones and computers, we utilize social media of all kinds. We exchange them through emails. We exchange them through many ways that and very frequently. So when we are exchanging so many number of images, and it does not matter what is the kind of machine you're using, whether you're using an Android phone or using a iOS phone, or whether you're using a Windows machine or Linux machine, it does not matter. When you're exchanging images, the images are exchanged across platforms, across machines, across kinds of devices. So if virus can be transmitted through the images, then it's a very difficult proposition to handle because it will spread like wildfire. Now, among the images also, JPEG is by far the most used format for storing images. This is the one of the most popular formats. Now, of course, there are other formats like PNG, TIFF, etc. But JPEG is by far a very popular format because this is most of the its popularity primarily because most of the camera manufacturers, they utilize this format for storage of images. This is a very powerful format, and it's got a high compression rate, so that is why it is very popular. Now, JPEG file format, if you study, it contains a lot of information in various sections. The information where the pixels in the image, they are stored as 8 by 8 frames, and they go through multiple stages of compression before arriving at the JPEG format. Now, these 8 by 8 frames, they contain information regarding the image which can be compressed, and then when you open an image file, it will get uncompressed, and you will see the original file. Now, what JPEG format designers they did was in 2010 they introduced an aspect in the JPEG file which is known as the EXIF tags. Now, EXIF tags basically is utilized for storing metadata of the JPEG files. Like you can store which camera took the image, what was the location. You can pin down the time of the time when the photograph was taken, and a lot of information. There are so many information that is stored in the EXIF tags. Now, these EXIF tags they can be altered by the users of the JPEG image. You can say, okay, fine, make the image brighter, make the image uh, what do you call dimmer, or stretch the image. You see that people who work on Photoshop, etc., they basically alter the image in various ways. So this is possible basically because of the EXIF tags, which is there in the JPEG files, and that's why they're able to do all that. Now, the problem is that the EXIF tags can be compromised because the hackers, what they can do is that they can introduce their malicious code into the EXIF tags, and through that the virus can spread through the images in which the hackers have put the malicious code. So this is possible. Now, this is the vector which is very, very dangerous, and which is very, very utilized by many hackers to spread virus in computers. So this is the experiment what we will do. How do we detect whether a image file that you are getting, it contains a virus or it does not contain a virus? Now, like we were discussing, why it should be a concern for the businesses. Now, in businesses, we have many channels through which all the employees of the organization interact with the world. They interact through the computers, cell phones, etc., and they utilize so many number of medias, etc., to exchange images. So now, if a hacker attacks any individual, absolute innocent individual with an image file which contains a virus, and if that enters into the enterprise network, then the entire enterprise can be compromised. So that is the danger, and that is the reason why the businesses should be concerned about virus entering through JPEG files into their enterprise. Now, uh, what do you call? We know that every business has to spend or spends a lot of money on antivirus, etc. Now, antiviruses, etc., what they do is that they basically keep on, you have to keep on updating the antivirus, simply because what they're doing, antivirus people are doing, is that they are updating the signatures what they're seeing in the world, utilized by different hackers, and when any file contains the signatures, they isolate that file. Now, this is a very expensive process because what do you call? There is a huge amount of research uh, which requires to be done uh, by the antivirus people. Uh, uh, it is labor intensive. They have to keep on hunting for signatures, and when the signatures are obtained, they have to update the database and distribute the database across to all the people who have purchased the software. Now, because it is an expensive process, every business also has to spend a lot of money in terms of keeping their antivirus up to date and having the antivirus license, so that every person in the organization is covered by the antivirus. So now this is, if you find out from your organization, if you are a businessman yourself, you would also know that it's a huge investment in terms of keeping your machines virus free. In terms of deploying what do you call uh, software which can prevent your enterprise from attacks. Now, uh, the problem is that in spite of having spending so much amount of money, there are lot of attacks which succeed. I have given you a few examples here, and you can see the extent of the damage what these attacks can do. Very recently, you would have known that there was a huge attack on Accenture, and though it is not disclosed yet how much was the money which was demanded, or how much was the money which was spent in terms of getting the enterprise back on track, but there was a huge attack and it was in news for quite some time. Similarly, a little while ago, there was an attack on the entire US government where the solar wind, you must have heard of the solar wind case, where the software was compromised, and then the entire, what do you call, government was compromised. So, so in spite of spending so much of money on antiviruses, still hackers are able to uh, find a way to make an attack and what do you call, cause a lot of damage. Now, this primarily is happening basically because the hackers, they are moving much faster as compared to the people who are working on preventing attacks. Now, this is because the way the attacks are prevented is by manual effort, where people are working very hard to find signatures, and then updating database, and then spreading the word across. Don't use this particular kind of software, etc. So this process, we discussed that this process is costly. At the same point of time, this process is also time consuming. So now the thing is that since this this is both time consuming and expensive, can there be a way where we could do it in a more reliable manner and at the same point of time feel more secured, uh, for by spending a lesser amount of money? Now, the experiment which I'm going to discuss with you today is in the direction that we will use the machines to detect the malware, so that if the machines detect the malware, the chances of what do you call, going wrong with the detection will be lesser, and at the same point of time, the machines will be much faster as compared to human beings in terms of making a detection of the malware. So if the machine does it, we will get results much faster, and the results can be more reliable. Problem is that the machine will only know how much it has been taught. That is, whatever data it has seen in the past, based on that, it can make all inferences for the future. So if there is an outlier case which comes about, then the machine obviously has not seen such a case in the past, so he will not know how to react to that. Now, this can be improved by supplying more number of cases to the machine, and as the machine learns more and more about viruses in our case in JPEG files, it will become more and more intelligent. So the machine can be made heuristic so that it keeps on learning and improves and comes to a stage where it is very reliably able to detect malware. So now let us go through the process how we could train a machine to detect malware. Um, okay. Do you think you will be okay? I will finish this because let us try to keep some time for the demonstration. Now, what was done is that in this experiment, I collected some 6,000 files which were clean JPEG files. Now, getting these files is not a very big problem, basically because I had a lot of photographs of my own which I had taken at different points of time. Also, I told my friends to send their photographs, and one of the reliable ways of checking that these photographs don't contain a virus is that I uploaded these photographs into Google Drive. Generally, if a photograph contains a virus, Google Drive will reject it automatically. So now that was then the difficulty was actually in collecting JPEG files which contain a malware. Now, so for this I got about 500, about 450 JPEG files containing malware from IIT Kanpur. Now, these files we analyzed, we opened up the files in a isolated machine and saw that yes, they contained C programs inside a JPEG file. If the file is opened, then this program could cause things like it could delete the complete hard disk or things like that. So, so this was the initial data what I got for the machine. So you see that I had both uh, clean JPEG files and JPEG file containing malware. Okay. So using this data, we started training the machine. Now, we like we were discussing, what do you call, the EXIF tags are the location which the hackers basically utilize to introduce the malware. The other locations in the JPEG file is not possible to introduce a malware, or it is very difficult, or it doesn't make sense. Um, so what was done was that all the data in the JPEG files contained in the EXIF tags was extracted, and then I found out what is the length of each EXIF tag which is there in the JPEG file. Now I try to figure out whether there was a pattern in that, and I try to tell the machine, okay, fine, take out the lengths of all the EXIF tags and learn from the lengths as to in the clean file and in the malware files, whether you can differentiate between the clean files and the malware file based on the length of the EXIF tags. Now this model did not perform very well. So the second model which I did was that I just extracted the EXIF tags as it is, concatenated the EXIF tags into a long string, and then formed a term frequency inverse document frequency matrix. Now this is TF-IDF. TF-IDF basically means term frequency in inverse document frequency matrix. Now here what we do is that each EXIF file, each JPEG file is taken as a document, and each term inside each of the EXIF strings what I formed from the EXIF tags was taken as a term. Now on one axis we will have the JPEG files, that is the documents, and on one axis we will have the terms, that is all the unique terms found from each of the JPEG files. Now we find out the frequency of each of the terms in each of the document and make a matrix out of that. Using this matrix, we try to see whether there is a pattern which emerges or not. So we will have patterns in this matrix which contains both information regarding the clean files and information regarding the malware files. So this strategy worked very well. I will share the results with you. Now, before we get on to the results, what was there was that you saw that we had around about 6,000 clean files and around about 450 malware files. So now this was a very imbalanced data set. So when you come across a data set which is imbalanced like this, we need to do some treatment. And what I did was that I did a what do you call I used a technique called oversampling, where I said, okay, fine, this data set which is small, you oversample that so that you bring it to the same number as the other data set. So this was done using a technique called SMOT, that is synthetic minority oversampling technique. So here, once we applied SMOT, I think we will have time to go through the code where we will be able to see that when we have about 450 malware files, we oversample it so that it becomes nearly equal to 6,000 records without losing the randomness what is there in the data that we have got. So after the oversampling was done, then we had a balanced data set. And then on that balanced data set, I applied an algorithm called random forest. Now, random forest is a classification algorithm as well as a regression algorithm. So I obviously utilized the classification algorithm for our problem. Using random forest, you can see that the results what we obtained was that It is as you are seeing on the screen right now. So here, what you are seeing is the confusion matrix. The confusion matrix basically states there are two cases here. One is benign, means it's a clean file or it's a malware file. So we have two cases where it's either benign or malware in reality. That is a true, really it is benign and really it is a malware, or it is benign as predicted and benign and malware as predicted. So you see here, this is this number, what you're seeing on the where I'm placing my cursor, is the true positives. That is, it is actually a benign file and it is detected as a benign file. So this is a true positive. And here we have the true negatives, where it's actually a malware file and is predicted as a malware file. So here we have true positive and true negative. Then here we have false negative. That is, it is actually a benign file, but it is predicted as a malware file. That is a false negative. And here we have false positive. So that is, false positive means it is actually a malware, but it is predicted as a benign file. Now, among all of these information, the one which is most concerning for us is the false positives. That is, if a file is a benign file but it is detected as a malware, it is not so dangerous, because even if we isolate that benign file as a malware, we will not lose much. It will not cause harm. But what will cause harm to us is that if a malware file gets detected as a benign file, then we will have an intruder in our system, and that is what is our main concern. So what encouraged from this experiment was that the false positive was very less. Like you see in the case of a COVID situation. So you do a test, you are actually not having COVID, but the test tells you you have got COVID. The situation is less dangerous as compared to you actually have COVID and the test tells you that you are not COVID infected. That is a more dangerous case. So this is, so our result shows that the false positives were very less. And in the verification, first it was on the training set and then on the testing set. So there were very few false positives that we got in the from this model. Now you see that the accuracy in the training was nearly 99.995%. That is, it's almost 100%. But when we are testing the model, we got an accuracy of around about 92.805%. That means this model is overfitting. That means when I'm training the model, it's learning the uh, data a bit too well. So when I'm giving him unknown data, he is getting slightly confused. Though it is not very alarming, but when it is seeing fresh data, it is getting confused. So this model has definitely got an element of overfitting. So this is definitely an area where the model can be improved. So, like we were discussing, the model suffers from overfitting, and when we made the term frequency matrix, there were more than 64,000 features. That means the model is definitely very complex. So we need to simplify the model. There are many techniques. Like one of the techniques which I have identified is the principal component analysis, PCA. So we will apply that. So next, what we have to do is that we have to simplify the model for making it more reliable. And since this technique works, we can apply higher predictive analytics, including things like neural networks, so that we get a much more reliable model. Now, I did the same experiment with ELF files. ELF files, you may be knowing that all the executable files which run on Linux machine or any form of Unix machine, that is whether it is Solaris or AIX or anything, any executable file is basically ELF file. So that is and all the IoT devices basically utilize Linux primarily. So it all the executable files on the IoT devices are also ELF files. So ELF file has got a huge utilization, and so it's a huge vector. So ELF files also attacked. So I took the ELF files and did an experiment on that using the similar technique. And it also produced good results. It gave an accuracy of 97% in training and around about 90% in testing. So this technique really works. So in conclusion, we can say that malware detection can be definitely done using machine learning. So that is the conclusion of my discussion. So if you have any questions, you can ask, or I will go and show you the uh, code which was utilized to generate this model. Madam, are the participants allowed to speak, or it is one directional? Okay, I guess the participants are cannot be allowed to speak. So I hope you're able to see my screen. So here is the way where we are building the model. So here you can see that it is a Python code. So first of all, we have taken the different libraries, what is utilized. Now, random forest models, etc. These are available in Python from the library called sklearn. So here the sklearn libraries are there. And what do you call? These are the libraries which is utilized for reading the image files. So these libraries are utilized for reading the images. And here we have the library for applying SMOT. We discussed that we were doing oversampling. So oversampling is done using this library called IMB learn. So now notice a few things. We do not keep any kind of hard code in the program. So we make constants. In Python, there is nothing called scope and all that. So anyway, these constants, they work. Then these are the programs, which is these are the functions which is utilized to extract information from the JPEG files. So so these three functions, I cannot share the code with you simply because this code is going to form a part of a book which we are going to publish. So, but anyway, I'm showing you the entire thing. So what we do is that we extract all the exif tags from all the files in a directory. This first time I have separated the clean files and JPEG files. So all the clean files are in one directory. I take the clean files and extract all the exif tags from the files. Similarly, I put all the malicious files in one directory and extract all the malicious files exif tags in a separate data frame. Once we have this, from these two data frames, I can find out what are the unique features that we discovered from the files. Once we have a list of unique features, we fill all the features into a data frame. So this is what this function basically does. Fills it in a data frame. So now we have two data frames, one containing all the features of a clean file and one containing all the features of a malicious file. So here we are doing the labeling. So here I say these are the clean files, and here is the labeling for the malicious files. So once we have these two data frames, now we have clear data regarding what do you call the clean and the malicious files. So I put the clean data and the malicious data in a single data frame now. So now we have a random data which contains the the features of a clean JPEG file and the malicious JPEG file. So this data frame can be utilized for the further machine learning purposes. So notice here that in the right now we have 2,719 clean files. That is 0 is clean and 358 malicious files. So this is where we were discussing that the data is imbalanced. So now there's some more thing to be done. That is, we need to replace all the character zeros. The character zeros basically is the null character. So if a null character is encountered, then the reading of the data will stop. So that will not allow our experiment to go on properly. So we remove all the null characters from the data. So once we have that, so you see that we have got records, which is 3077 records in two columns. One is the string containing all the exif tags, and one is and two columns is second column is the class label, that is whether it's a clean or a JPEG file. Now, once we have done that, we do further cleaning. We drop the not available data, etc. All these things we must be knowing. So this is ultimately the data set what we have. Now from our data set, we form the term frequency inverse document frequency, TF-IDF. So here we have this library which can make the TF-IDF. So this TF-IDF is created. Now if you see here, like I was discussing, this particular case, the TF-IDF contains more than 45,000 features. So there are more than 45,000 terms which has been extracted from these files. Now that is a huge, this is going to make the model very complex. So uh, anyway, we have that, and now we use the oversampling using SMOT to after the oversampling, if you see that we have the same number of clean files and same number of malicious files. So now the data has got balanced. So once the data has got balanced, we can form our model. So we have, what we have done is we've created the TF-IDF, we have applied oversampling, and we have got the balanced data set. So now we are proceeding to make the model. Now, actually what I did was that I made two models. One was using a decision tree classifier. So one was a decision tree model and one was a random forest model. The results were almost the same. So if you see that using the decision tree model, when we do the cross validation, it gives a accuracy of around about 99.061%. So this is in the training. The accuracy is around about 99.061%. And then we fit the model, and after fitting the model, when we take out the uh, uh, classification, we see that there is no false negative. So there absolutely no false negative. So this is a very good result. And if you see the accuracy, it is very high accuracy. Uh, then using the same data, we create the random forest model. The random forest model also, if you see, the accuracy is now even higher at 99.975%. So this is even higher accuracy. And then after we fit the model and we draw the confusion matrix, we get this result. We have discussed this. So once we have the model, we can make predictions using this model. So to make predictions, we need to, now these are the test files. These files have not been read in the machine so far. So we read the test files, and after reading the test files, we form the TF-IDF, and then the TF-IDF has to be put for analysis. So we do the TF-IDF, replace the null character, we do all the steps, whatever is required. Once we have the data in the format that we require, then we put it for prediction. So here you see I'm putting the data what we have extracted from the test files for prediction. So once the predictions are made, using the prediction, we draw the confusion matrix, and the confusion matrix is showing like this. So this is how we make the predictions. So then we try using the same model for making predictions on the using the random forest model as well. So so I have walked you through the entire code as to how we can utilize machine learning for creating a model for detecting malware in JPEG files. Now the question is, where can you utilize this? The thing is that we can have this model and we can make a what I have done is that I have made a web service. The web service basically calls the model, and uh, what do you call uh, any file, if it is supplied to the web service can extract the information from the file and ask the model to tell you whether it contains a virus or does not contain a virus, and the result can be what do you call replied back by the web service to the calling client. Now what I can do is that I can, supposing I have a program which allows me to allows me to upload files on the cloud. So when I'm uploading files onto the cloud, these files will go and store in some location, some directory. So I can have an observer on this directory, a file watcher. So moment a new file comes into this directory, it can be picked up and sent to this web service. The web service will analyze whether it contains a virus or not, and if it contains a virus, the uploader will remove the file and delete it, or take some action to quarantine it. So this is the way this model can be utilized in the practical business environment. Okay, now we are in the end of this presentation. So what do you call? If you have any questions, I am open to take the questions.
You can write in the chat box, or you can write the questions in the chat box. If any one of you has a question, you can write in the chat box. Or maybe like I can give you access permission to the mic. You can have your queries. Any questions? Anyone having any query? Okay, so I think we are not getting any query. Partha, you can continue with the session.
Yeah. Okay. One minute. I will share the screen once again. So, like I told you, this is the experiment on the JPEG files, and I told you I've also done the experiment on the ELF files. Now, ELF files are slightly different. So the ELF files contain a file header, a program header, and a section information. So here the information is slightly different than the JPEG files, and the information is lot more. And the information contained is numeric and strings both put together. So here also we have a function to extract all the information from the ELF files. So these are a lot of functions which I wrote for extracting information from the ELF files. Then once we have the information, you see that here we are having a case of multi-class classification. What I have is that I have ELF files which are clean, that is benign files. Then I have files which contain backdoor viruses. I have files which contain botnet viruses, DDoS viruses, Trojans, and other viruses. So now we have files which contain multiple type of viruses and also the clean files. So here I extract the features from all the different type of files that we have, that is a clean and different type of virus containing files, make a feature list out of that. Then I create a data frame out of a single, so you see here I created a single data frame from all the features extracted from all type of files. And here is the distribution. That is, we have 2000 clean files, and then all the different type of viruses, we have this many number of files. So here, if you notice that the number of clean files and the virus files are almost the same. So we don't require to do any kind of balancing of the data. Anyway, we have around about 5000 records, and we have more than 2500 features. So now we do some cleaning of the data. After we do the cleaning of the data, we create a random forest model on this data. So once we do that and find out our results. So here is the result we got during the training. So we notice here that here there are some false negatives. So these areas, what I'm highlighting with the cursor, These are areas where where basically we get the false negative, where the classification is incorrect as compared to what it should be. These are also incorrect, but here they are falling into the category where they are the dangerous side of it, like we discussed. But these numbers are also not very alarming. So this is still a reliable model that you can utilize for detecting malware. And if you see here, we have so many classes because this is a multi-class classification. So this is the example what or what I showed you for a multi-class classification. Now this is the area where we are testing our algorithm. So this is the result what we get during testing of the algorithm. So um, now I have come to the end of my session. So unless you have questions, I think we could take leave. And
Okay. Partha, we are getting the question in the chat box. Naveen, I'll just
yeah, I think some question has come in the chat. Yeah, is TF-IDF if TF-IDF is a smoothing technique to pick out outliers out of general? No, no, no. TF-IDF is nothing to do with outliers and smoothing and nothing like that. It is term frequency matrix is basically a matrix which contains the you would have heard of the term called TDF, the term document frequency, or DTF, document term frequency. So these are matrices where we have the documents on one side and the terms on one side, and we have a count. The count can be various types. We have a count of how many occurrences of the terms we have in each uh, uh, for each document, or how many documents we have for each term. So TF-IDF is nothing to do with smoothing or anything to do with outliers. No.
Okay, do we have any other query? You can write in the chat box, or you can raise your hand. Yeah.
Can we have a name of the tools which has been used? Okay, like I told you, this is basically a Python program. The main library which is utilized for making the model is scikit-learn, scikit-learn. Scikit-learn is the main library utilized. Then I also pointed out to you the different libraries which is utilized for SMOT and reading JPEG files and ELF files, etc. So in terms of tool, it's a Python. That's about it.
Any other questions? Any question from your side? Okay. If any question is coming up, just let us know so that we can have the answer. Okay, I think Partha, the participants, they do not have any query right now.
Okay.
Okay.
I hope you found this useful. And in case you have any questions, you could send it across to IMT and I will try to answer through them. And thank you for your attendance and attention. It is very grateful that you had the patience to listen through the complete session. What do you call concentrating for 1.5 hours is not a joke. So thank you very much.
So, okay, I feel privileged, Partha, to thank you for sparing your valuable time on Sunday evening and giving your insight on the very relevant area of security challenges in images and how these can be resolved using, machine learning techniques. So the session is an eye opener for all of us. And thank you all the participants for attending the session, and the IT team for your all time support you always provide to us. And thank you once again, Partha. So if there is any query, definitely they can come to me or they can write, to IMT CDL and we can contact with you.
Yes, I'll definitely try to answer that. Thank you very much.
Okay, thank you so much.
Thank you.
Thank
Bye.
you. Bye bye. Okay, Partha, you can leave the meeting and all the participants, you can also leave the meeting.